One of the main parts of this course is using integration as a tool for adding up. So let's remember where that comes from. Let's begin by considering a function f of x. So if we plot it against x, it's going to be some line over the x-axis. Now, Newton taught us that if we want to know the area under some part of that curve, say between x equals a and x equals b, then what we should do is to integrate from a to b the function f of x dx. And that is that area between the curve and the x-axis between a and b. Now, what would we have done before Newton taught us this? What we would have done was to divide that area into lots of little rectangles at position x1, x2, x3. They have height, fx1, fx2, and so on, and we can make them all of width, delta x. So we learn that the area is equal to a sum over all of those rectangles of the height at the nth position times delta x. Of course, if we want to get this area exactly the area under that curve, we would have to make these rectangles arbitrarily thin. In other words, we would have to take delta x goes to 0, which means that the number of rectangles would go to infinity. Okay, but now we can see from the first and second line that we have the key result, which is that if you want to add up fx of n delta x over some range, such as this, then you can get that answer by integrating. And that's what we will use throughout this course in order to do these sorts of sums. Now, of course, each time you do it, you can go back and rethink this argument, but the notation is set up to remind you how it works without you having to sort of go back to basics. So the sum becomes an integral, f of x becomes f of x, and the delta x becomes the dx integration.